In this video, we'll see existential quantifiers. These are quantifiers we use to specify existence of at least one element or even some elements in the universal set for which a given proposition, open proposition or predicate is true. For instance, if I pick this proposition, P of x, says that x squared is less than or equal to 0 with, let's say, the universal set, the set of all integers, then P of x, as you can see, P of x holds only for a single element. If you take any element, any random element except 0, x squared can't be less than or equal to 0. But the only number that x squared less than or equal to 0 can be true from this set is 0. So there is at least one element. This time 0 squared is now equal to 0, hence it is true. So existential quantifier is used to represent such an existence in a universal set. So what do you mean by existential quantifier? So this is how we represent the phrase there exists an x, or for some x, or for at least one x is called existential quantifier. Existential quantifier. So existential quantifier is denoted by, and it is denoted by the symbol. As you can see, this is capital E written in the other way around. So we change the direction of E to represent the existential quantifier. So existential quantifier indicates existence of at least one element or some elements in a given universal set where a predicate is true. As an example, you may take the following example. Let's say the universal set is the set containing -1, 0, 1, and P of x is, let's say, absolute value of x greater than 1, greater than or equal to 1. In this case, P of x is true for -1 and also for 1. So for -1 and 1, this is true, but not for 0. Hence one can say there is an x such that P of x holds or is true. Similarly, if I choose another set, let's say Q of x, say that x squared is plus 1 is less than or equal to 1, in this particular proposition. X squared, if I put -1 here, -1 plus 1 is 2, 2 is not less than or equal to 1, and again 1 plus 1 is 2, which is not less than or equal to 1. But if I put 0 here, 0 squared plus 1, which is 1, 1 equals 1. Hence, Q of x is true at least for one element, or is true in this case for exactly one element in this universal set. Therefore, one can say this statement, there exists q of x, there exists an x such that q of x is true. This is how we decide whether a given quantified proposition is true or not. In this time, the existential quantifier indicates at least existence of one element in the universal set where the open proposition can be true. So to say that a given open proposition augmented with existential quantifier is true, we need only one element at least. Okay, at least one element must be there so that the given open proposition is true. So to say that statement quantified with existential quantifier is false, the statement must be false for every possible element you choose from the universal set. So that's how we decide truth value for a quantified open proposition.